before I forget. I have done that before. Okay, it's recording. Fantastic. All right. So thanks for joining. Like I said, I know tomorrow's a holiday, but honestly, if there was any session that you had to join, I would say that this one is the one. So you made a good move by joining the session, because there's a reason also why I separated this part from. So basically, this is still part of learning unit 6, which is probability distributions. The thing is, I did discrete distributions in the last session, and I kept the normal distribution for another session, which is today. And because it's quite different, there's a lot of things you need to absorb to understand how to answer questions for the normal distribution. And this part, this normal distribution, carries over to later learning units. So you'll use it for hypothesis testing. You'll also use it for sampling distributions. So it's very important that you understand it now, um, before you move on to the next learning units. All right, so if ever you need to ask questions, this is the session that you really need to ask questions if you're not understanding something, and tell me to stop or just go back and explain something. All right, so with that being said, let's get to it. I'm going to share my screen, and please give me a heads up if you cannot see my screen. Okay, so I'm just gonna wait, hold on, I haven't shared it as yet. Okay. Okay, I'm going to the whiteboard. Tell me if you see what I'm sharing with you, which is basically a table on the right. It says table 1 and white space on the left. If you can see that, just say yes. If you don't, no. Okay, all good. All right, so let's go back there. All right, so you have to become very familiar with using this table. This is in the back of your textbook. Uh, in your appendices, look for table 1, but it's given in your formula sheet when you're doing the exam. All right, so it's part of that, and you need to understand how to use it. All right, so how I'm going to approach this session is I'm going to show you how to use this table. You don't need to know right now what it's used for and how it's actually how to make sense of it in real life. You just need to know how to use this table to pull out probabilities. Okay, all right. So you're given this table, and you can see there's a chart, there's a graph on the top, right? It's a bell-shaped curve, and on your horizontal axis, the line here that runs horizontally, that's your z-axis. So it's actually a number line, right? So I'm gonna sketch it on the left here. All right, so there's this number line. This number line is actually your z-axis. So it's z, right? Now z goes all the way to minus infinity. So it doesn't stop at 0, right? It goes all the way from minus infinity to positive infinity. Okay, all right. So that's your z-axis. Now for different values of the z-axis, right? The z can take on any value. You can find those values on the margins of this table. So for instance, say I wanted z of 0.24, right? So say I'm looking for z equals 0.24. All right, if I'm looking for that, then what I do is I go down the left margin, look for 0.2, and there it is here. And basically, this margin going down gives you one decimal place as well as up to a whole number. So there's 0.2, but I'm looking for 0.24. So the second decimal place is on the horizontal margin. So it's here. There's your 4. So if I combine that, that's 0.24. That's how I find my z values. All right. If I'm looking for, say, z equals 1.23, all right, looking for z equals 1.23, then I go down the margin for z, looking for 1.2. There we go. There's 1.2 here. All right, and the second decimal is 3, so it's here. So where these two intersect, which is about here, that's how I find my z values. Okay, they're located on the margins. Right. Now the values inside the table. The values inside the table everything, I'm going to put a, let me do a different color here. Let's go with blue. So everything inside this table here that I'm shading in blue, everything inside here are probabilities, or in other words, they are the areas that you can see in this graph here. So let's say, for instance, I want to know the area, right? Now this graph here only gives you the area from 0, as you can see here, from 0 to any z value that you specify. So if I want to know the area from 0 to say 1.2, right? So if I want to know, say, here's 1.2 in your z-axis, 1.2, and z is on the left of it, so there's 0. And then let me just get to this curve as well. Okay, it's something like what I'm doing here, but obviously my freehand drawing is not the greatest. Okay, so if I want to know the area from 0 to 1.2, I can find the value for that area inside this table. All I need to do is find out where 1.2 is for your z. So there's 1.2. There's your z of 1.2. There is no second decimal. It's 1.20, so it's the first value here. So the area is 0.348, sorry, 0.3849. So this area here is 0.3849. All right, let's do another example. All right, let's say I want the area from 0 to, so going from 0 to say 0.32. So let's give a z value of, this is our z axis, 0.32. Now I want to know the area from 0 to a z value of 0.32. So I go to my table, I look at where z is 0.32, so there's 0.3. The second decimal is 2, so it's here. So where they intersect is here. So that's the area, 0.1255. So this area here is 0.1255. I'm just going to pause there for a second and just ensure everyone's following me on how to use this table to find areas. And if you're given any z value, then you know how to find the area from 0 to that z value. Is anything unclear before I move on? Going back to the chat. Thanks, Stefan. Thank you. Fantastic. All right. So, all good. Thanks, Marty. Okay. All right. Let's get back. But yeah, if you're not sure about anything, please ask away. All right. Now, the area that we're finding. So look at this last example I did, right? All right. This last example that we did, we found the area to be 0.1255. Now, why is this area so important? Well, the area is actually a probability, and it's the probability of z being between the lower limit here, which is 0, and the upper limit of 0.32. So if I write it out mathematically, probability, the lower limit is 0, and how we say something is between something is mathematically we say the lower limit less than z less than 0.32. So that probability is this here. It's what we found from the table, 0.1255, which is why you'll never find the value inside this table to be greater than 1, because they're all probabilities. So as we did in the top example, here we looked at the area from 0 to 1.2. So what we actually worked out is the probability of z being between 0 and 1.2. And that happens to be what we've worked out from the table, 0.3849. So that's why the area is important. It gives you the probability of z being between 0 and whatever z value you are looking for. All right, so let me just clear this out. and I will ask you a question and you can work this out. I'll give you some time just to put an answer in the chat. Okay, so say the question was, what is the probability, write it out here on the top, so get you can use the table that I have here, or if you have your textbook, you can just refer to the same table in the back. So the question is, what is the probability, right, of z being between 0 and 0.41? 0.41. Can you give me that probability? You can pull it straight from the table. Or yeah, the table is probably clearer in your textbook if you want. What is that probability? Give it a shot. Doesn't matter if you get it wrong. Okay, so far someone's got an answer there. Yes, that's right, Stefan. Very good. Excellent. So you looked at where you can find Z 0.41. Fantastic, well done. And that's basically where these intersect. So you go horizontally and then vertically where they intersect is here. Excellent. Very good. Does everyone else get that? All good? Okay. Thank you, everyone. All right, good, good. Okay, we're getting there. All right, so now this is, you're getting it. This is like the hard stuff. There's just some kind of, I guess there's always a twist somewhere. And this is where it comes along, all right? Now, if you notice all the Z values in your table, all the Z values, they're positive values, all right? You can see this value goes from 0 all the way down, and then even on the right, it's 0 all the way to the right. But the thing is, like I told you, the z-axis doesn't stop at 0. Okay? If you look at the table, there's 0 here. But the table goes all the way to negative infinity. So here, you can have values of z that are negative. So for instance, say you're asked to work out the probability from negative, so now the lower limit is negative 0.41. Okay, so negative 0.41, right? And now the upper limit is 0. Okay, so now it's a negative value and the upper limit is 0. So if I had to draw this curve, it's roughly, all right, 0 is where it's centered. If you look, this is a better sketch than what I'm doing, but you kind of get the idea. Now, this is where we use the property of symmetry. Now, what is symmetry? Symmetry is basically, it's symmetrical. So it's like a mirror image about the line of 0. So if this is the line of symmetry at 0, then what you see on the right is exactly the same as what you see on the left. That's what symmetry or symmetrical actually is. So if you knew the area from positive 0.41, if you knew the area from 0 to positive 0.41, then because of symmetry, it is exactly the same as negative 0.41 to 0. So I'll shade that area with green just so you can see the difference. But the size of the area is the same. The green area and the blue area is exactly the same because of symmetry. So that's why we use that property. We use that property to solve this. So that means this is the same. It's exactly the same as if we switched it around, but with the positive z value. So that means going from 0 less than Z less than positive 0.41. All right, and maybe I should have put that writing in blue because it matches up with this. That's what I was trying to say, but you get the point. All right, so that is, and that's exactly what you just worked out before, Stefan. It was 0.1591. So it's the same thing. These two areas are the same. It's 0.1591. So this is 0.1591 because of symmetry. Okay, does that make sense? So when you're given negative Z values, you use the property of symmetry to solve it. Fantastic. Great. Good. You've pretty much got, you've become comfortable with working out probabilities for the normal distribution. Right, these are, let me see a question. Give me a second. Can you give me, yes, we should. So basically you can get asked like questions that kind of mix up, that forces you to kind of use these properties to work it out. So let's say this here, all right. I'll give an example to kind of clarify what I was talking about. And it's very important that you get this part right. And if you're getting this part right, this is kind of the hardest part, because the rest of it is actually quite easy. It's just basically trying to use this table to get the probability. All right, so let's say I'm going to use a different color. Let me go with black. All right, so let's say now you're asked to work out the probability from negative 0.4, right? But instead of always having a 0 and all, let's make it 0.61. Let's go with that. So now you look at the area from a negative 0.4 to positive 0.61. So what you do here, and for me personally, I sketch it. It always gives me a good idea of what I'm actually looking for. All right, so I'll leave it to you if you want to adopt that method. Oops, something like that. Okay, remember it's centered at 0. All right, and this is our z-axis here. All right, so we're asked to work at the area from negative 0.4. So remember, negative values on the left of 0. So let's put it here. Remember, it doesn't have to be accurate. It just needs to be a rough sketch. So there's negative 0.4. All right, and then on the right, the upper limit is positive 0.61. So here, 0.61. All right, so we want to know the area between these two values. So I am going to break this up into two parts. I'm going to shade the area from negative 0.4 to 0 as green. Okay, so you have an idea here, and I can distinguish the two sections. And then the remaining area, let's make it blue. The remaining area here, from 0 to that, is in blue. Okay, so what the solution is to this problem is basically getting the green area and getting the blue area and adding them up, because that's the total area. That's what we want. We want to know the area from negative 0.4 to positive 0.61. Now the blue area is very easy to find from the table. That's what you've been doing all this time. Okay, you just need to look at where z is 0.61 and there's 0.6. So 0.61 is here where they intersect. It's exactly what you were doing earlier. There, it's 0.2291. So this blue area is 0.2291. Now the green area is where you're going to use symmetry, because now we got a negative value. So remember, this green area is the same thing, right? It's the same thing. Let me put green so you don't, don't confuse you. This green area, it's the probability. Remember, it's the same as its positive counterpart, 0.4. all right? It's the same as its positive counterpart, which is going from 0 to positive 0.4. And that in the table is here. There's it here, 0.1554. So the green area is 0.1554. And so our answer is basically adding up these two areas. So you add up the 0.1554 to the 0.2291. That's our answer. You add them up and what you get will be the answer. All right. So any z value is positive. Yes. So the table only gives you z values. So if you're asked to work out the area from a negative z value to whatever, then you just switch it around and look for its positive counterpart. So basically, what I have here, what I'm underlining here, this is the same thing as negative 0.4 less than z less than 0. So you can see these are switched around. The 0 was in the bottom, now it's in the top, and this was a positive 0.4 on the top, but now if you're going to make it on the left, this becomes a negative. It's basically that symmetry property I was telling you about. There's 0. So if this is positive 0.4, that's negative 0.4. What I'm saying is the area from negative 0.4 to 0 is exactly the same as the area from 0 to its positive counterpart, or its equivalent. Stefan, does that make sense? That's pretty much what these two equations are saying. Fantastic, fantastic. All right, is everyone okay with this? This is the hardest part actually. If you got this down, so how do we know? All right, okay. So how do we know which column to use? I'm a little confused on how you got 0.2291. Okay, 0.2291. All right, let me. The board is a bit busy here, so I'm gonna just clear out the unnecessary stuff. Okay. Let me remove this because I'll start again. Okay, so this is the question, right? The question is, find the probability of z between negative 0.4 to positive 0.61. Now, if you look at the table that's given to us in our formula sheet, this table only gives us areas from 0 to z, right? It doesn't give us a value from any negative value to that positive z value, all right? So in order to use this table to solve it, you need to break this up into two parts, right? You're going to break it up into two parts. One part going from negative 0.4, so this part here, and then the second part is going from 0 to positive 0.61. All right, you're going to break it up into these two parts. So this part here, let me put this in blue. So let me put it in green. This part is probability going from negative 0.4 Z to 0. All right, that's this part here. Okay, now the other part, the second part, if I can just click color. This part is going from 0 to positive 0.61. 0 less than z less than 0.61. I'm going to pause there just so you make sure everything's clear. Okay, so do you understand how it's broken up into two parts? Fantastic. All right, great, great. All right. Now, this part, let's just look at the second part now, right? This black part here. All right. This part we can get it from the table directly, because the table, remember what we said earlier, the table gives you the area from 0 to any positive z value that you specify. So there's your z values. Your z values are running along the margin, like here. These are your z values. And then if you wanted the second decimal place, then you use this part here. All right. That's how you get the z values. So if I want the z value of 0.61, then going down this margin first, we look at where 0.6 is, and there it is here, 0.6. And then the second decimal is 1. Remember, it's 0.61. So the second decimal is 1, and there it is here. So if you combine that, you get 0.61, and there is the area. So that value of 0.2291 is this here. That's the area. That's the probability. Because area and probability are the same thing. So that's how you get your 0.2291. And that is this blue area here. This part here, what I'm doing, it's this, you're working out the blue area. So this blue area is 0.2291. Does it make sense? Fantastic. Awesome. Awesome. All right. So that's how you get the blue area. And then the green area, I showed you. Is everyone okay with the how you get the green area of, what is that? What does that have? What does it have? 0.4. It is 0.1554. Everyone good? All right. Fantastic. All right. All right. Maybe explain one more time. No problem, Stefan. All right. Okay. So Stefan, just before I go on, you get how I got the 0.2291. That part you get. Are you okay with that part? Okay. So it's just this green part now. The first part, this part here, right? Now I'm going to show you how to get that area. Now remember, this is going from negative 0.4 to 0. But because of symmetry, going from negative 0.4 to 0, it is exactly the same thing as going from 0 to positive 0.4 because of symmetry. Okay, this is a P. All right? This and this are the same because of symmetry. So going from negative 0.4 to 0 is the same thing as going from 0 to positive 0.4, because remember, it's a mirror image about 0. So there's your 0. Right? So if that's positive 0.4 and that's negative 0.4, then this area is exactly the same as this area. Okay, which is what you're saying here mathematically. So I understand the symmetrical. Well, why do we drop the negative sign? Okay. So the negative sign. You just okay. So kind of, if I understand, you're saying why does it? It's here. It's negative 0.4, and then when we do it here, there's no negative, and there's a positive 0.4. So is that your question? Okay, fantastic. All right. Okay. I'll explain this to me. Clear out the whiteboard. Okay, let me put this somewhere else. All right. The reason being is, okay, so here's our z-axis. Okay, it's centered at 0. So bear with me, I'll get to the point where you're asking. Okay, now there's 0, right? Now you were asked to work at the area from negative 0.4 to 0. So let's just forget this was 0.1, 0.61. Forget this part now. Let's just say it was 0, right? We were asked to work at the area from negative 0.4 to 0. In other words, what is the probability of z being between negative 0.4 to 0? All right, we were asked that. Now, if you look at our table, right, now the z values that we have in our table, there is no negative values. If you look at it, it starts at 0, then it's 0.1, 0.2, etc. So it just keeps increasing. The lowest value you can get for 0 is 0. You can see here, 0 intersects with 0 here. So the lowest value you get for z is 0. So the thing is, how do we find a negative z value? We can't, all right? You can't find a negative value. So that's why we have to use the symmetry. And if I understood, I think you understand why the symmetrical part, but why do we drop the 0? And that's because I need to write this probability here, which is probability of negative 0.4 less than z less than 0 in terms of a positive z value, because the table only gives you positive z values. If you look at your graph on the top, it tells you that this table will give you any area from 0 to a positive z value, but you need to tell it what positive z value. So in other words, I need to rewrite this in terms of a positive z value. So that becomes probability. Now I'm going to switch it around, because now I'm going to look at its symmetrical part, the area from 0 to its positive z value. So if I can find this blue area, that is the exact same thing as this black area, what I was being asked for. So that's the same thing as z going from 0 to positive 0.4. And that I can find from the table. You just need to look at where z is positive 0.4, which is here. And there's no second decimal, so the answer is 0.1554. 1554. So does it answer your question? Does it make sense as to why we drop it? It's because the table doesn't have negative z values. You need to rewrite it in terms of positive z values. Does it make sense? Find the value, we leave it. Yes, because you're only interested in the area. The area is what the answer is. So, all right, okay. Fantastic. Yeah. All right, because the area is the probability, and that's all you were asked for. You were asked to work with the probability that z is between negative 0.4 to 0. All right, so I'm just going to ask one more time, is everyone okay with this? Because now I'll show you how to apply it to like a real world problem before I move on. All good? Let's get a thumbs up. That's where I was a bit confused. No worries. No worries. All right, now let's apply it to a problem now. All right, to a real world problem. This is the kind of problem you can get in excuse me, in your exam. So let's read this question a bit. A recent survey by a local municipality established that daily water usage by its household is normally distributed. So I'm going to underline certain parts because we're going to refer to that. But okay, so it's normally distributed with a mean of 220 liters, right? And then a standard deviation. That standard deviation of 45 liters. So the mean, all right, symbol for the mean is mu, like this, right? Average. That mean is 220. Right, so that's the mu is what you see in this formula here. and then your sigma is your standard deviation. Sigma is 45. Right? This is from your earlier learning units. All right, so your mean, the symbol for mean is mu, and sigma is 45. All right. Now the thing is, the question is use the standard normal Z table. So that's the table we've been working with all this time. Whoops, if we go back, it's this table here. This is the standard normal table, right? So it's telling you to use that table to answer the questions that follow. So let's just look at the first question. I'll ignore the second question. Let's just look at question one. We're going to answer question one. It's saying what percentage of households is likely to use more than 300 liters of water per day? All right. Percentage is the same thing as probability. All right. It's the exact same thing. So if you're asking what percentage of households is likely to use more than 300 liters of water per day, then they're asking what is the probability that a household uses more than 300 liters of water per day. All right. So this question here says, I'll just read it one more time, and then I'll start writing down some maths to kind of break this down. A recent survey by a municipality established that the daily water usage by its households is normally distributed, with that mean 220 and a standard deviation of 45. So you need to let some random variable, right? And the general convention is we let x be that random variable. And what are we measuring? If you read this problem, we're looking at water usage, daily water usage. Okay, so we're using, we have daily water usage that will be represented by x. So x is your daily water usage. Right, now if x is your daily water usage, if you look at the first question, it's saying, what percentage of households is likely to use more than 300 liters of water per day? So if x is daily water usage, they're asking you x greater than 300. Right? That's what this part is. More than means greater than. Right? So they're asking you, what is the probability? And like I said, percentage is probability. What is the probability that x is greater than 300? That's what they're asking you. Okay, so I'll just pause there. Does everyone understand what I've done so far? I've let x be a random variable representing what we're trying to measure, which is daily water usage. And then I've formulated the problem mathematically. Okay, fantastic. All right. Now, once you've formulated it like this, right? Now, if you look at what I've written, I have it as x, but all this time we've been dealing with z. All right. So if you look at the table that we have, this doesn't measure. It doesn't. It's not a table for every sort of measurement. For instance, now we're dealing with water usage. This table doesn't represent water usage. Okay. We could have problems that we're looking at measuring the mass of, say, certain product. So this table won't represent that mass, right? So what this table here actually is, it's basically, it's a unit that that's a common unit. Let me try and express this differently. Okay, let's say let's say Stefan wrote a test out of 50, right? He wrote a test out of 50, and he scored, let's say, 20 out of 50, right? Hypothetically, let's just say he scored 20 out of 50. Okay, let's make it 40 out of 50, right? Stefan, you scored 40 out of 50, all right? And then Caroline, you wrote another test out of 200, right? You wrote a test out of 200 and you scored 100. So you scored 100 out of 200 and Stefan scored 40 over 50. But the thing is, you two wrote different tests that have a different limit. So how would you compare your results to each other, right? And that's pretty, I'm sure you've been writing tests and exams all this time. What we do to make it a unit that we compare, no matter what the test was out of, is we convert it to a percentage, right? And a percentage is measured out of 100. And that way we can compare Caroline's score of 100 over 200, which was 50%, and Stefan, you scored 40 out of 50, you scored 80%, right? So what we did is we converted it to a percent. Everyone gets that analogy of percent before I move on? I just thumbs-up marks there just to give you that kind of comparison. All right. So it's hypothetical. Please, I just thumbs-up marks, please. Okay, right. Okay. So just like how you get that percentage, this Z table it's the same thing. You can convert any unit to a Z score, any unit, no matter what it's measured in. So you can have something that's measured in mass, someone can have something measured in temperature, someone can have something measured in speed, velocity, whatever. You can convert it to a Z score using this formula here. Don't worry about memorizing it. It's given to you. Okay, so that's this thing here that I put in the block. This is how you convert any unit to a Z score. You take that X value that you have, you subtract its mean, and you divide it by the sigma, which is why we were given this. You were given this so you can convert this 300 to a Z value by using what you see in this block here. So how you do it is, now I'm going to change it to a Z. So you go probability. I'm just, instead of writing X, I'm going to write Z straight away. And how I change it to a Z is I take whatever X value I get. In our case, it's 300. I subtract its mean. I'm following the exact same thing I see in this box, minus its mean. And here's its mu. The mu is 220. So I subtract 220. And then I divide that by sigma, right? As this formula says, divide by sigma, which is 45. And that will give me a Z value. So I'm just going to write the value out. If you punch this in your calculator, you'll get this is the same thing as probability of Z greater than, I think it's somewhere, I think it's 1.7 something. Yes, thank you, Caroline. Thank you. So this is 1.778. Let's get there. 1.778. All right, now we can go back to using that table. All right, so now we got Z greater than 1.778, so I'll sketch it. This is my Z axis as 0. So here my curve, something like that. Remember, this is perfectly symmetrical. This is where, remember, it's positive 1.778. So 1.7, I'm just going to round it to one more place because the table only goes up to the second decimal. All right. So here, now I want you to pay attention with this problem here, right? It says Z greater than 1.78. Okay. So remember, I just rounded it to one more place. 78. Greater than. So if I had to sketch this on this graph, greater than 1.78 means I'm interested in this area, the area that's greater than 1.78. So I'm shading this here. All right. I'm going to shade this area here. Now, if I find this area, then that's the solution. That is the answer. All right. But remember, if you can remember the diagram in our table, it only gives you this area here. It gives you the area from 0 to that value. Okay, so I can get this area, this turquoise, I guess, this color, right? I can get this turquoise area. Can you give that a shot looking at your table? I'll go to the table. So remember the Z value is 1.78. Okay, the Z value is 1.78 here. So here, 1.78 is the cutoff. And I want to know the area, the probability from 0 to 1.78. Whoa, everyone's got on 0.4625. Do we leave the answer Z? Stefan, okay, so let me get your question first. So there's a reason why I rounded to 2 decimals. And if you, the reason being is, can you see this table? It only goes to 2 decimal places. So if you wanted Z of 1.778, it won't go up to that. It'll only go up to 1.78 here. That's why I rounded it, because the Z values go up to 2 decimals. So that's why 1.78, there's 1.7 here, and where it intersects 1.78 is somewhere here. I drew my line here. That's why it's 2 decimal places. That's why I use 2 decimal, because the Z value only goes to 0.08. Stefan, does that make sense? No, no, you won't lose marks. No. Karen, I think you got the probability 0.4625. Excellent. Well done. Well done. Yes, that is it. Let me go back to that board. This turquoise area that you got, this area is 0.4625. So if I remember it correctly, 4625. Well done. Yes. All right. So that's the turquoise area. But remember, I need this other area, this dark blue area instead. Now, what you need to remember for the normal curve, right? This graph here. Let me just put a different color. Okay, so here, let me just do it here. There's your z-axis. There's your curve. That's okay, and it's centered at 0. Now remember what I said, the area is probability, right? So you'll never get a value that's greater than 1. So the entire area of this curve, every single thing, the entire area sums up to 1, right? But remember that I told you it's symmetrical. So that means the line at 0 splits it exactly in half. So that means half this area on the right of it, everything on the right is 0.5, and everything on the left is 0.5, because the total area must be 1. So if half this area is 0.5, right? So let's just look at everything on the right of this. If half of that is 0.5, and that means if you've worked out this part to be 0.4625, if this part is 0.4625, then what would be this remaining blue area? Remember what I just said? Half of this area, everything here is 0.5. That's the total area on the right of it is 0.5. And if you've worked out that a certain portion of it is 0.4625, then what would be this blue area here? Remember what I said? Everything to the right of this is 0.5 area. And if you've taken up 0.4625, then the remaining area is 0.5 minus this. It's the remaining area. So it's 0.5 minus 0.4625. That is exactly it, Caroline. Yes, that is it. That is exactly what, what you just said. So there is a small blue area that you're trying to solve, all right? This area here is 0.5 minus 0.4625. It's this area you subtracted, and that's the remaining area. So you should get like 0.0375 or something like that. Yes. Yes. No, no, no worries. I completely get what you meant. Does everyone get that? Everyone? Anyone lost? I'll just go over it again one more time, all right? So just let me know if you're not sure about anything. So the property of, let's check if any questions. Got it. Okay, so that's good. Okay, but I'll just recap it just anyway, right? So you can just bear with me. So the property of the normal distribution, the entire area of this curve, every single thing adds up to 1. This entire area is 1. But like I said, because of symmetry about 0, it splits it like a mirror image. So half the area on the left of it is 0.5. Half this area for this different colors. So half this area, this red area on the left, this is 0.5. And then the remaining area here, that is also 0.5, because it must add up to 1. So you split it up into 0.5 and 0.5. All right. Now, if you know half of that is 0.5, then you can use that property to work out values on the extreme right, like how I've done here. Because remember, your table will only give you areas from 0 to a z value. But if you want the area on the right of that z value, then you need to take 0.5 and subtract what you get from your table. You subtract this area and you get the remaining area. All right. Yeah, that is actually what I wanted to cover today. And you know what? The second question is actually quite easy. You can take a screenshot of this. It's very, very easy. But what I've actually done, which is one better than this, you can watch this video again and give this problem a go. I'll write the answer out, and you can see if you can get that answer right. I'll write it out in a second. If you try out the second question, it's saying, what is the probability of finding a household that uses less than 100 liters of water per day? Right. So if I'll tell you the answer that you should work toward. It's 0.0038. So the answer you should try and work towards is 0.0038. That's what you should work towards. 0.0038. All right. Now there's a reason why. Yeah. Also, I'm not doing this. I want you to try and work out yourself as an exercise. I've made a practice test available for you to work out to actually work through this section. All right. So don't worry. The marks are not going to count for anything. It's actually I'm going to actually give it a time. So you have a limited time to do it. So once you're comfortable with this collab and you think you understand this, I want you to give that test online a shot. I'll make it available from tomorrow. But yeah, you can do it. I'll leave the date all the way till when your ISTARs are due. But like I said, don't stress about the test. You don't have to do it. It's your choice whether you want to do it. I wanted to make it available so that you can give it a shot and see whether you understand and get feedback from it. All right. I'm going to time it because I want you to actually also get used to trying to answer stuff like within a limited amount of time, because that's what your exam is going to be. So I'm trying to help you prepare for that exam. So the test is entirely based on this, the normal distribution. All right. So let me just check. Can you put it on again when we're preparing for exam? Yeah. Okay. Give me. You know what? I might actually just leave it all the way till your exam and give you multiple tries. Maybe that might be a better idea. But yeah, sure, Stefan, no problem. I can do that. All right. But so yeah, I will make that available for you. It seems like everyone's understood this really well. But a nice way to just check if you're following as well and you think you got it down is try the second question out. Give it a shot, right? So you have to formulate it in terms of x, then you will map it to a z-score using this function, this equation here, and then go to the tables and find the probability. And then yeah, I'll make the recording available and I'll make that test available for you. All right. Any questions? Because that's it from my side. You're welcome, Marty. No problem, Caroline. And thanks for joining, everyone. Like I said, this you can see this is not something that's really quick and easy to grasp. I'm very glad that you joined and you understand it. So enjoy your evening, your fake Friday, and enjoy your holiday. Make the most of it, everyone. Yes, it's tricky, Mahi, but you will get the hang of it if you just work through problems. That test is, I suggest you will try it out. Yeah. All right. Have a good one, everyone.